In this video, we are going to find the derivative of cosec. We know that cosec is the reciprocal of sine, so cosec is 1 over sine. So if our f of x is cosec x, it implies that f of x plus h will be equal to cosec x plus h. And we know that the definition of the derivative of a function is given by, if we take the derivative of our function cosec, we shall get the limit as h tends to 0 for now f of x plus h. Here we have cosec x plus h minus cosec x upon h. So let us replace cosec with 1 over sine. So the derivative of cosec will therefore be the limit as h tends to 0 where we have cosec, I'm going to write 1 over sine of x plus h, then minus 1 over sine x upon h. Just changing cosec to 1 over sine. Now, this is the same as the limit as h tends to 0. I'm going to simplify the denominator and put it under the same under 1 LCM. So if I find the LCM here, I will get sine of x plus h times sine x so this will be sine x minus sine of x plus h, then over h. So this can be written as the limit as h tends to 0 Now I want you to first observe here that here we have sine x minus sine x plus h. Now this is a trigonometric identity which can as well be written as 2 cos x plus h divided by 2 sine x minus x plus h divided by 2. From this identity, we have already looked at it in the derivation of sine. So sine A, if you have sine A minus sine B, this is the same as 2 cos A plus B divided by 2 sine A minus B divided by 2. So I'm going to apply it here. So that's right. This is going to be 2 sine, I beg your pardon, it is 2 cos. Now I'm going to take a plus b, that means x plus h divided by 2. This will be 2x plus h divided by 2, which is x plus h over 2. So this one here is going to be x plus h over 2. Then sine, I'm going to subtract. When I subtract, I'll get x minus x plus h. Definitely we'll get negative h. So I write negative h, but remember sign is affected with a negative, so I'm going to put a negative here. So I just write h over 2. Then divided by the error of this and divided by h. So I'm going to write it at once. This is divided by sine x plus h, that's sine x again divided by h. Alright, so I'm going to continue simplifying this expression here. Now when you see it is sine x, which is not bothered about the h, so I can pull this sine x out. So this can be written as the limit as h tends to 0 beg your pardon, let me first bring x 1 over sine x. We bring this 1 over x out because it is not affected by the h. So I get 1 over sine x times, now the limit as h tends to 0. I'm going to also pull this negative out, so I write negative 1. So now here I'm left with cos x plus h over 2, sine h over 2, and sine x plus h. So I can write cos of x plus h over 2 times sine. Yes, we continue. Now we also have sine h over 2, but there is a 2 here, don't forget it. So I can write sine h over 2 over h. I'm just rearranging, so this 2 and this h combined, then I'm left with sine x plus h. So times 1 over sine x plus h. Yeah, I'm interested in obtaining this whenever I see it appearing, because this one always reduces to 1 when you have sine h over 2 divided by h over 2, or when you have sine of an angle divided by that same particular angle, you just get 1 when you have the limit as that angle tends to 0. So that's why when I combine this 2 and this h and I obtain this, I simplify the work. Now at this level I can apply my limit. When I apply the limit to the bracket, here the derivative of cosec x will thus be -1 over sin x times, let us apply the limit. When we apply the limit, this is x plus h over 2. So h over 2, as h tends to 0, that means this is 0 plus x, we remain with cos x times (1), because this is sine angle divided by the angle. As h tends to 0, this reduces to 1 times. Now this is 1 over sine x plus h. Now as h tends to 0, this becomes x plus 0, so we remain with 1 over sine, which is negative. Now I want to observe that we have 1 over sine, which is cosec, and we have cos over sine, which is cot. So you know cos over sine is cot, so we get negative. Oh, you can see 1 over sine, 1 over sine, that is 1 over sine squared. So we take 1 over sine is cosec x, then cos over sine is cot x. We conclude, therefore, the derivative of cosec x with respect to x, you get negative cosec x times cot x. That is how we derive it from first principle. So you need to memorize this because it will save can save you some energy when you have some complicated numbers. It saves time.